Good morning, everybody. It's Sunday morning. I think it's June 28th, and this video is probably not going to air for quite some time because, unfortunately, I'm really backed up on videos. It's not that I haven't been doing much. I've got a lot done, but I just haven't had time to do the editing. The editing takes up quite a bit of time, and then the uploading. Got a DSL line, and it's not that great as far as uploading times go. Typically I have to start an upload before I go to bed and just let it run all night, and it'll usually be uploaded by the next morning. So anyways, I wanted to do a little work on the Vernon today because it's raining outside, so I'll be able to get some time down here on the Vernon. I ended up finding information in an old South Bend publication called How to Trim Your Lathe, or How to Keep Your Lathe Trim, I believe is what it was called. And it tells me about setting the bearing clearance on an old South Bend cone head between 1 and 2 thousandths. So that's what I'm going to do here on the Vernon, because the Vernon appears to have the same type of bearings as some of the early South Bends, which, by the way, I have now determined apparently is phosphorus bronze is what that alloy is that those bearings are made out of. They're not a Babbitt material, and they're not, obviously they're not cast. So I'm going to try and set that. I'm going to try and set the end play on that, and if that all goes well, then I might even try and put the whole, probably the next thing I'll do is I'll put the arm on the back, probably move the lathe into position, put the arm on the back, put the drive on, put a motor on it, maybe get it spinning, and give it some tests and see how it sounds, how it acts. And then if all that pans out, then I'll go back to putting back together all of the gear train for the carriage. I want to do a little quick epilogue on the last flea market finds video I did, where I showed all that stuff I picked up at the QVEAA, that one box I got a steal on for 20 bucks. Couple of things. I had shown you guys this huge indexable end mill that was brand new, and I was lamenting about how it's 1.25 inches, and I doubt I'm going to be able to use it on my Wells index once I get that repaired. This is probably for a big CNC mill or something. Well, I had this end mill holder that I had bought off of a guy at an auction, and it's got this nice big carbide roughing bit in it. I think this is 1 inch. So I was like, well, I thought that was my biggest end mill holder, but then I went back to the original cabinet here that came with the Wells index, because I remember that I saw something in there that looked like an end mill holder. And what was in there was this thing, and it's got a slitting saw on it. But I figured that what this was is a, I just had a wrench here. What did I do with it? I'll just do this anyways. So what we got is we got a big end mill holder, and the guy turned a piece of aluminum to make an arbor for a slitting saw. So he had this in here like this. It's missing one of the tightening screws, and I'm not convinced whether this is actually an original tightening screw or just something that somebody made or put in there. But the good news is it's 1.25 inches. So this big end mill holder will accept this. So if somewhere in that box with all of those bits that are in there, carbide inserts that are in there, if I have carbide inserts that will fit this, then I'm certainly going to give this a go on my mill when I get a chance. I think it might be fun to see how this works. One other epilogue for that series is I had these few items here that I had absolutely no idea what they were for. There's a few of these devices right here that I had shown you guys have the little point on the end. Some small versions here in these, and I got some larger ones here. here's the one that was not in a container. So this little thing, it's like a pin. It's got a sharp point on the end, and it's got this flat on the back. And I didn't know what this was. Well, the DAPRA marking system written on one of these tubes, this one here, that is what I ended up using to figure out what this is. This is actually a solid carbide bit used in a system, some sort of a machine that is made by this company for what's called, what the heck was it called now? Oh, something peen. No. Pin marking. That's it. Pin marking. I think if I understand this correctly, what this literally does is this makes a bunch of tiny little dimples right next to each other on a piece of metal, and the dimples are so close together that when you look at it with your eye, you can actually read what it says. Now, this is like silk screened on or something, but I don't know if you've ever seen that. I don't think I have an example of it, but I've actually seen writing like that that looks like a whole bunch of little dots that we use to make that writing, and apparently that's the kind of method that they use. And this little carbide, solid carbide pin is actually pretty expensive, and they're consumables, I guess. And then I had noticed that on some of these they actually say resharpened by CTC. So apparently when they get worn, you can send them out and have them resharpened just like any other carbide cutter if you want, as opposed to replacing them. I guess because they're solid carbide, they're kind of pricey. I only found one completed auction. I didn't find any of these on eBay, and I only found one completed auction for these on eBay. Guy had 11 of these. He wasn't sure if they were new or if they were used, and he sold a lot of 11 for, like, I can't remember now, but it was like close to $200, I think. So apparently these little suckers are pretty expensive. So I'm probably going to end up doing the same thing. Also, these also have something to do with that marking system. These parts I found in here that were marked Electromark IMG. So I haven't looked these up yet, but these are also probably going to just end up being eBay things, because I don't think I'm ever going to get to use this. But the interesting thing about these components here, these Electromark components, is I think that this company actually specializes in making signage for the safety industry. You know, all those kind of regulation signs, the danger, high voltage, and stuff like that. So, I don't know. So these might end up being very hard sells, or they might be something that end up, I might be able to get my 20 bucks back from just this few extra things that I can't use. So, that's pretty much it. Oh, I don't know if you can see this big cone gear assembly here. This is actually from the old Brown and Sharp Mills gearbox that I scrapped a while back. I kept the gearbox, and I've got somebody who needs one of these gears, so that's why this is apart. I think at this point I'm going to stop here, have a little more coffee before it gets cold, and then start digging into that cone head. So the first step that I need to do is I need to figure out exactly where these shims should go. It's obvious to me now that I've taken this cap off that the shims have to sit on this surface here, because this actual half of the bearing surface where the bearing is cut in two is actually below the level of this. So what ends up happening is when this cap gets put on, this surface right here goes down inside there. So I can't put shims down in there, because if I put shims down in there, well, they'd have to be very narrow for one thing, and secondly, there'd be the danger of them getting out of position and actually coming in contact with the
with the spindle. So what I've got to do is I've got to put shims here. Now on the south bend there are 2 bolts in the front and the rear, and the shims actually are basically flat pieces of metal that have 2 U-shaped slots cut in them so that the shims can actually be put in and removed without having to completely remove the cap. Furthermore, the shim pack is called a laminated pack because what it is it's a whole bunch of thin little shims that are together in a pack, so that when you buy them and you stick them in, and if you decide that you need to reduce your clearance, you take the pack out and you literally peel off like the top layer, and that'll drop it down. I think each one probably drops it down like a 1 or 2 thousandth, which is really fine and dandy. Well, a couple of problems with that for my situation here. First off, the south bend one, like I said, has 2 slots. Okay, and even if it didn't, the second problem is that shim pack, laminated shim pack, sells for around $50. Now I don't know whether or not that's just because they're hard to get, or if they're hard to manufacture, or if people on eBay are just taking advantage of people. I don't know. All I know is that there's no way that I'm going to end up using that because like I said, it won't work. It's got the slots in the wrong places and yada yada yada. So what I'm going to do is I've got some pieces of shim stock here, and hopefully I've got something that will work up to be the magic combination of what I need for clearance. So the first thing I've got to do is I've got to put the cap back on and put a feeler gauge in here and see if I can't determine exactly how much of a gap there is to begin with, because I knew when I had this tightened down to the point where it wasn't locking the spindle up that there was a good sizable gap on the outside here. So we're going to start by doing that. Alright, so I cleaned up the mating surfaces underneath here, and I also just cleaned up these screws. I cleaned up around the heads to make sure there aren't any burrs or anything, and cleaned up this section here, re-cleaned the threads again, and hopefully that'll help ease the removal and installation of these screws, because I was having trouble with them. And part of the trouble is because they've got to be tightened evenly. You can't just torque one down and what happens is the whole thing tilts and gives you a problem. So I've got to be careful about how I handle tightening these. See right there, that head is not going down inside there, so this one is. Now this one is. And so I'm just sighting down the spindle end and checking out how the gap looks, trying to keep the gap even on both sides as I tighten this. Yeah, it looks like the gap on this side is wider. There we go, just felt it move down a little bit. If I could tap right on the middle of the bearing cap here to seat it, it would be helpful, but that oil cup's in the way. Guess I could take the oil cup off for now. How tight that is. Alright, so it's locked up right there. Alright. That gap is huge. Alright, so I measured this little piece of packing and it's about 32 thousandths. It goes in there no problem, but it doesn't go in on the back side. So that tells me that I actually want to loosen this back one a little bit. And Let's see. So if I tighten this front one, that should bring the cap forward. Okay, just tighten down on that. 30 thousandths shim in the front. And it's still free there. And now I can get the 30 thousandths shim in the back. But I bet you if I tighten down on it, it's going to lock up. Why is that not? It's interesting that that doesn't want to tighten down any further, even though I'm not. Alright, so 30 thousandths in the rear. And over 30 thousandths in the front. And it's grabbing. So yeah, so we need to have more in the front and the back. Well, I do have a lot of this flashing material, and it's pretty uniform thickness, around 10 thousandths, and cuts easily, so it's easy to work with. So I think I'm gonna try putting in, right now, another 10 thousandths won't fit in the front, and I've got the back tight, so I'm gonna try putting 10 in the front, 10 in the rear. I'll see how that tightens down, and if it's free, then I'll test for the free play clearance. That's a little tight. But before I contemplate figuring out how the heck I'm going to subtract 1 or 2 thousandths from 2 shims that the thinner of which is 10 thousandths, I think instead what I'm going to do is I'm going to check and see exactly what the end play is right now, or the bearing clearance is. So I'm going to get set up for that. Alright, so I've got my indicator stand on the carriage of the lathe. I've got the best test indicator pointer is resting on top of the this part of the spindle here, and now I need to get a bar. The manual South Bend book says you should have a 12-inch bar, or a bar approximately 12 inches long that you insert into the tapered end of the spindle and pull up on. And the 12 inches is supposed to tell you roughly how much force you're supposed to be putting on this when you're trying to do this. Ironically, it doesn't tell you how far to insert the 12 inches in there. Because I have one, I'm going to use this brass bar. Pulling up on that pretty hard, and it's not moving a bit, which would indicate to me that I have no oil clearance in there. That would explain why this feels a little tight. Just loosen each one of those screws about a quarter of a turn. This is turning a lot freer now. Oh, my indicator is still sitting on there. Oh yeah, it definitely is. Let's try that again. There we go. So that's about it's about 1.5 to 2 thousandths right there. So I know when I'm tightened down on both of these shims that I don't have enough clearance in there. So that means I've got to add a very little bit. So the only other shim stock I have is this stuff right here, which is 22 thousandths. Oh, which is coincidentally the same as my flashing. I thought my flashing was 10 thousandths. I guess I was wrong. And it occurs to me I also do not have anything on the back side here. And what may be happening is this cap may be tilting a little bit this way. I'll play around with this some more. Alrighty, well I searched high and low, and I remembered that buried somewhere in that tool cabinet that came with the index mill that I had thrown a bunch of sheets of thin material that I had found in there, figuring that it might come in handy at some point. And I found a thin strip of stainless steel, and measures out at 35 thousandths. Now 35 thousandths is pretty much what the two pieces I had put together already were giving me, but I only had them stuffed under the front here, and again I was talking about the possibility of maybe that cap is being pulled down in the back more. So I want something that spans the whole thing. So I cut a couple of strips of this 35 thou stainless that are long enough now so that I don't have them in there far because of the screw. I haven't notched them out yet. But I've got them in there so that they're shimming the back and the front. And I just tightened it down, and I come over to this side and I give it a spin. It's not bad. Not bad at all. So now I'm going to swing my indicator back in position, and I'm going to see what I've got for clearance. Alright, well I swapped out that brass bar that I was using because I was actually able to bend that brass bar. So now I've got a steel bar in there, and I put a rag around it so that I won't, I didn't want to mar up the inside of that bore. So let me zoom in on this indicator and show you guys what I'm looking at. Can't tell if that's focusing on that or not, but I've got it zeroed right about there. So you should be able to just see the little blackness of the indicator. Needle moving. I wish this camera was focused on this stuff, but I guess I need a new camera. So if I push down, I can get it to move about 2 divisions, which is 1,000th, and then if I pull up, I can get it to move almost 2 divisions. So total movement side to side is, I'd say, within the 1 to 2 thousandths range where I want to be. So I'm kind of liking that. And it's moving freely. But it just occurred to me that I don't think I have, I don't have the rear bolts for the headstock in, so I probably should make sure that I'm not flexing the entire headstock up, which is quite possible. Alright, I've got all the bolts in the headstock, and still got the same amount of deflection pretty much as I had before. So I'm pretty satisfied with that right there. So I think what I'm going to do is I'm going to take these shims out, I'm going to notch them to account for the bolts so that I can get them in further, and try it again. Okay, so what I did was I took it out, I cut this notch in it to go around the bolt, and then I tapped it in as far as it would go, and then I scribed a line, took it back out, cut it, trimmed it. So now when I tap this in all the way, it should end up being flush on the outside. I mean, I could have even left it with those little ears hanging out, but that would leave me those sharp little edges of metal sticking out there, and at some point I might be taking the chuck off or whatever and catch the back of my knuckles on it and pay the price. Alright guys, I'm going to talk loud because the downdraft blower for the cook stove in the kitchen directly above me is roaring, blowing the delicious smell of my wife's spaghetti sauce down here and making me hungrier. What ended up happening was I put this all together, and I notched out those shims, I put it all together and everything, and even though it seemed like it had 1,000th and a half clearance, this still felt kind of tight to me. And then I realized I had forgotten to put the belt on, so I knew I was going to have to take it apart anyways. So what I decided to do was I took the caps completely off, and just for the heck of it, I added 2 more shims. I had some stock that was around just under 10,000, and I put 2 more of those shims in, 1 on each side. So I effectively raised this whole cap supposedly 10,000ths of an inch. Thinking that was going to be way too much, I decided to try it anyways. So I've got this tightened down really good now. First thing I notice is, let me take this bar and rag out of here so it turns freely. First thing I notice is now it's spinning nice and freely. So I'm not worried about that now. And I just checked, and lo and behold, now when I pull up on this, I'm getting, well, I gotta zero it. I don't have my reading glasses on, so I'm just gonna put it to whatever mark that is. So that's 12 divisions, which this is a 1/2,000th indicator. So 12 divisions, so that's 6,000ths play I've got in there right now. So as I suspected, those 10,000th shims are just too much. So ideally, I think what I want is, like, if I've got 6 in there now, and I want 2, so I got to drop this down 4,000ths. If I've got 10s in there now, and I want to get rid of 4, I want to take the 10s out and put about 6,000ths of shim in there. And I don't have anything that's going to let me do that. So what I have to do is I have to buy some shim stock so I can do this right. For the time being, I'm going to press onward, so to speak, pardon the pun. Oh, this isn't a press, I don't know why that would be a pun. With the way the things are now, I'm just going to leave it, because I can mess with this down the road. So right now, with that much play in there, I'm just probably going to get more chatter than I should. So one way was too tight, the other way is too loose. What are you going to do?
Hey guys, just want to give you an update. What I ended up doing was I went into the city and I bought from one of the suppliers that had some in stock. This is a Precision brand shim stock. This stuff comes in a roll. I bought stuff that's 2 thousandths thick. This is 100 inches long, 6 inches wide. This will last me forever. But it was only about $9 only. But it got me out of my bind here with my shim problem. And plus I'm going to make more shims for the other side, and if I work on other equipment down the road and I need some shim stock like this, it'll come in handy. So what I ended up doing was I left my stainless steel shims that I had put together, that I had made, I left those in there. But then the other shim that I had made yesterday on it, which was on the front one I used, I think 10 thousandths, and on the back one I had used actually just an old feeler gauge that I had found in that South Bend junk, and that was 8 thousandths, so it wasn't even. And the problem, of course, was it was nice and free, but I had way too much play when I would pull up on the bar, way too much clearance, which if I ran it that way would create problems, mainly excessive chatter. So what you didn't see me do tonight was I left the stainless in there. I took out the 10 thousandths and the 8 thousandths on this side. I made 2 shims. That stuff is paper thin, so it cuts easily with scissors. I cut 2 shims, put one on each side, so that was 2 thousandths on each side. Tightened it down. It felt a little tight, and I had virtually no clearance. So then I loosened up the cap, cut 2 more 2 thousandths shims, added those, and feels nice and free, which is what I was hoping for.